In this video, let us discuss about the bag of words and TF and IDF. Right. So we all know that making machines to understand text is being a challenge. So how the challenges can be overcome, right? See, for example, the human beings are able to understand what the other people are talking to us within a fraction of a second. But can you imagine machines to understand that? What they have to do? So they need us to break down the text into a numerical form so that the machines will be able to understand the text in the form of numerical. So this is where the concepts of bag of words and TF and IDF come into play. So let us try to understand how these BOW, which means bag of words, and tf-idf, right? So those techniques help us to convert text sentences into numeric vectors, right? Okay, so let us try to understand that. Okay, so just imagine that people are going to watch some movie. So once they watch the movie, they will be writing some comments about the movie. So can we say that all the comments or all the feedbacks will be of the same level, or all the feedbacks will be the same? It is not, right? So one person may say that the movie was really good. The other person may say that the movie was not as expected. The person 3 may say that it is a normal movie, nothing much different from the other movie. So something like that, right? So we may get any kind of reviews from the people. So now we can see contrasting reviews about the movie. And like here, when you look at 10,000 or 1 lakh reviews about these, we can get a lot of interesting insights about each, about the movie from different perspectives, right? So we cannot simply give these sentences to the machine learning, because we know very well that the machine learning models will not be able to handle it. It cannot basically analyze whether the statements or whether the reviews are positive or negative. So what are we trying to do? We have to do some pre-processing techniques, right? So that is what we have to do, right? So like a pre-processing, not only pre-processing, like we call it a sentiment analysis, like that has to be done, right? So here we are going to discuss about a bag of words as well as tf-idf. Okay, so first let us understand how to create vectors from text, right? So that's what I said. There will be text, right? So there are texts. So basically there are some reviews. So reviews in the sense like that is in the form of text, and that has to be converted into the form of vectors, right? So this is what we are trying to do. Fine, right? So the technique that we use over here is called as word embedding, where we can represent the text using vectors, right? So we are going to look into two popular word embedding techniques. One is BOW, which means bag of words, and the second one is tf-idf, which means term frequency, inverse document frequency, right? So by the end of the video, you will be clear with both the concepts, right? So let us try to understand what are bag of words model. So when you look at the model, this is actually the simplest form of text representation in numbers. So as the name suggests, it is a bag of words. So it is a bag of word vector. Word vector means nothing but a string of numbers. So let me tell you that it is a technique that is used in text modeling, and it is a method of feature extraction with the text data. And this is very simple and flexible way of extracting features from documents. Now look at this. There are 3 statements over here. This movie is very scary and long. This movie is not scary and slow. This movie is spooky and good. So now when you look at these three statements, it is saying that very scary, here not scary, here spooky. This looks like very scary and long in the sense. Sometimes we can think that as a negative statement, and here not scary and slow is also looking like some kind of negative statement. This looks like a positive statement. So how are we going to make the machines to understand whether the review is positive or negative, right? So what will happen is, first a vocabulary will be created for the unique words. So what will be the vocabulary consist of? So that could be this movie is very scary. So let me underline all those vocabulary now. 1, 2, 3, 4, 5, 6, 7, right? And 9. And scary is already there, and is there, is there, maybe the slow, and then this is there, movie is there, is there, spooky, right? So what is happening here? The first step is that vocabulary is generated. A vocabulary is created, right? Now the next step is that we can now take each of these words and mark their occurrence. How many times it has occurred? Say, for example, if I take this, you can see that here there is one this, here there is one this, here there is one this, right? So this is how we are going to see that, like the occurrence, the number of occurrences being identified, right? So review 1, review 2, review 3. So this one movie is very scary and long. In the first statement, there is no not, no slow, no spooky, no good. If you take the second statement, it is given that this movie is not. So not in the sense where it's not here actually like scary, right? And the second time it is saying that scary is already there, right? And is slow, right? So you can see that slow over there, right? So where is the slow over here? And here you can see one over here, right? So this, the third one is this movie is spooky and good, right? So where is that and good? So now you can see that like now the vector is being written as 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0. So the length of the review in words is 7. So the second case, 8 words. So let us see over here, 1, 2, 4, 5, 6, 7, right? So what is the error over here? Let us try to find out that. I think this movie is not scary, right? Actually, that is there. So there should be one over here. So this movie is not scary, right? Is not scary, right? And is, so 2 is there and 2 is slow, right? So 1, 2, 4, 5, 6, 7, 8, right? Right? So this is basically 0. So we are getting it as 8. Hope this is clear, right? Okay, fine. So the third step is that this movie is spooky and right, spooky and that should be like a good, right? And that should be like a good, right? So now what you can see over here, 1, 2, 3, 4, 5, 6, 7, right? So how many are there? Basically, here there are 7 words, right? Because the statement is this movie is spooky and good, right? So there should be this movie is okay, so spooky and good. So basically this is also right. So let me make the change over here. So this is 6, right? So hope this is clear now. Now you can write it in the vector form, right? So this is being the number, whatever is being written over here, that will be written in the form of vectors over here, right? So hope this is understandable, right? So let me clear this now. So like you can look into this, the quick brown fox jumped over the lazy dog's back. Now is the time for all good men to come to the aid of their party. So if you look into this word aid, in document 1, it is not there, but in document 2, it is there for once. And all in the sense, like if you look into this here, there is 1 and 0 back, right? So if you look into this back, actually 1, document 2, it is not there, right? So this is how it is being there, right? So document 1 and document 2, it is written over here. So if you look into this, these are all stop word over here, right? So we know what are stop words, right? Which does not bring any meanings, right? So if you look into this, you can say that maybe here for is not meaningful, and like is not meaningful, of else of. Okay, so whatever are the stop words, so that list can be taken, right? So this is about bag of words. Now let us try to understand what are the drawbacks of using this bag of words model. So here we can see that we will be facing issues when we come across the new sentences, because it can work only for the available sentences. So if the new sentences contain new words, then our vocabulary size would increase, and the length of the vectors also will increase, right? So additionally, the vectors will contain many zeros, and so that it will result in sparse matrix, actually, which is that we would like to avoid. So the vectors would also contain many zeros, in the sense like we could see zeros over here, right? So basically we want to get rid of it, right? And also we are retaining no information on the grammar of the sentences, nor on the ordering of the words in the text. We are not bothering about that also, right? So this is about the bag of words model. Now let us try to understand what is term frequency. So tf-idf is another statistic that's intended to reflect how important a word is to a document in the collection or corpus. So what does that basically mean? TF is equal to, that is term frequency is equal to number of or occurrences of word in particular document divided by total number of words in document. Okay, so let us understand that in the numerator, n is the number of times the term the number of times the term appears in the document, and thus each document and term would have its own rule. So how can I understand this? So in case if you take the same example over there, right? So same vocabulary we can use like that, what we used in bag of words model. So let us try to understand. So vocabulary is this: movie is very scary and long, not slow, spooky and good, right? So the number of words in review 2 was equal to 8. So a term frequency for the word this. So let us try to understand that number of times this appears in review 2 divided by number of terms in review 2. So that is how it is being taken. Say for example, when this movie is taken, out of 8, how many plays this movie has occurred, right? So I have taken the second sentence. So you can see that in the second sentence, movie is okay. So let me write the sentence so that it would be helpful to understand it little more. So I can say that, okay, so let this be the sentence now. Now what you can see over here, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, and slow, right? 1, 2, 3, 4, 5, 6. Okay, twice I have typed that, right? So you can see that there are 8 words over here. Movie has appeared only once. If you take is has appeared twice, that's why I have written 2 by 8, which is equal to 1 by 4. So very is not there, that's why we are writing it as 0. And scary is there only one time out of 8 and has appeared only once. So this is how it is being written. So hope this is clear. So this is how term frequency is being found. So we can, let us write for all the 3 sentences now. So review 1, review 2, review 3. So for all the cases it is being written, right? Okay, clear now? So now let us try to understand what is this inverse document frequency. It is a measure of how important a term is. So how we find is like we will be finding the logarithm of number of documents divided by number of documents that contains that particular word basically, right? Say for example, here we can say that how many statements are there? 3. So in case if you are trying to find out no this, okay, let us take this as the example. So how many documents are there? 3 documents. So how many in how many times it has appeared in that 3 times? So what I can write now, log of 3 by 3, which is equal to log of 1. So what I'm trying to say over here is how many documents are there. So here actually we were talking about 3 statements, right? So we were talking about 3 statements over here. So basically that will become 3 divided by how many times that word appears in all documents. So if you look into that, this has appeared in all the 3 documents. So log 3 by 3, that will be equal to log 1. So what will be the answer now? This will be equal to 0. So similarly, you can find out for all the other words too, right? So you can find out for all the words 0. Movie has also appeared in everything. So 0 is 0. Very 0.48. Scary 0.18. So what do you understand from this? So here you can see that is this and so these are all having idf as 0, which means that it has less importance. But if you look into that, scary is 0.18, long is 0.48, and if you look into that, good is 0.48, right? There are few words which are really important to understand how the movie is like. So these all have low values, and it means that it has more importance, right? So now what are we trying to find out? We are trying to get TF into IDF. So what does this basically mean? Term frequency into inverse document frequency, right? So this is what we are trying to understand. So what is this term frequency? Term frequency means the number of times divided by the number of terms in the document, right? Number of times it has appeared divided by number of terms. And IDF is nothing but number of documents divided by number of documents with that particular word, right? So this is what we have seen. So now let us try to understand this. This is being written over here, review 1, review 2, review 3, and we have IDF. We are finding out tf-idf, tf-idf, tf-idf for all the cases, right? So now we have got the tf-idf scores for the vocabulary, and tf-idf also gives a larger values for less frequent. So if you look into this is less, movie is less, is less, but you can see that very more, here it is less. So now you can compare all these scores. Basically it will tell you that tf-idf gives larger values for less frequent words, and it is high when both tf and idf are really high. So whenever tf and idf are really high, it is giving us a higher value, right? When both tf and idf are high, we are getting it as the higher value. So what can we conclude from this? tf-idf gives large values for less frequent words, and it is high when both values are high, right? So the word is rare in all the documents combined, but frequent in a single document. So what we have seen here, bag of words just creates a set of vectors. Bag of words just creates a set of vectors containing the count of word occurrences in the document. while tf-idf model contains information on the more important words and less important ones as well. And a bag of word vectors are easy to interpret, but tf-idf usually performs better in machine learning models. So hope this is clear to you, right? So this is the understanding about bag of model and tf-idf. Hope this is clear to you. Thank you.